Welcome to today's ArXiv CS Digest for May 8th, 2026. We received 1,037 new computer science papers today across 59 subfields. Let's dive into the top picks. Trend 1 of 5, Quantitative Methods and Analysis. These papers employ diverse quantitative methods for rigorous analysis, modeling, and optimization across various complex systems. This cluster covers 181 papers. Representative work includes chase-like decoding, test pattern design and performance analysis, privately estimating black box statistics, and normalizing trajectory models. Trend 2 of 5, LLM reasoning and agentic behavior. This trend explores enhancing LLM reasoning and agentic behaviors for robust, efficient, and adaptive performance across diverse tasks. This cluster covers 259 papers. Representative work includes LLMs improving LLMs, agentic discovery for test time scaling, conformal path reasoning, trustworthy knowledge graph question answering via path-level calibration, and VexSysc, improving confidence-informed self-consistency with reasoning trace clustering and candidate answer selection. Trend 3 of 5, reinforcement learning algorithms and agents. This trend advances reinforcement learning algorithms and agent capabilities across various domains and learning settings. This cluster covers 162 papers. Representative work includes Flow OPD, on-policy distillation for flow matching models, reinforcement learning for exponential utility, algorithms and convergence in discounted MDPs, and goal-conditioned decision transformer for multi-goal offline reinforcement learning. Trend 4 of 5, advanced machine learning and applications. This trend applies cutting-edge machine learning models and paradigms to solve complex, real-world problems, enhancing efficiency, robustness, and understanding. This cluster covers 221 papers. Representative work includes zero-shot imagined speech, decoding via imagine-to-listened MEG mapping, graph, structure-aware localized conformal prediction on graphs, and DRES, dual reconstruction, smoothing for functional regularization. Trend 5 of 5, applied computer vision and 3D. This trend explores advanced computer vision and 3D methods for perceiving, generating, and interacting within complex real-world scenarios. This cluster covers 214 papers. Representative work includes 123D, unifying multimodal autonomous driving data at scale, MMBIR, efficient visual state space model for event-guided image reconstruction, and surgical visual understanding SURGVU dataset. Up next, our first paper out of 5, Evolver, Self-Evolving LLM Agents Through an Experience-Driven Lifecycle by Roan Wu and Batian Shi from Zhejiang University. Let's break down its key contributions. The authors introduce Evolver, a novel framework specifically designed to enable LLM agents to systematically learn and self-improve from their own experiences, addressing a critical gap in current agent capabilities. This contribution focuses on Evolver's complete, closed-loop experience lifecycle, which allows agents to iteratively refine their problem-solving strategies by continuously learning from their interactions. The system leverages an offline self-distillation stage where the agent's past interaction trajectories are synthesized into a structured repository of abstract and reusable strategic principles. During online interaction, the agent actively retrieves these distilled principles to guide its decision-making, and a policy reinforcement mechanism then iteratively updates the agent based on its performance. Up next, our second paper out of 5, Metric Unreliability in Multimodal Machine Unlearning, a systematic analysis and principled unified score by Abdullah Ahmad Khan and Ferdas Sohail from Murdoch University. Let's break down its key contributions. The authors present the first systematic study specifically examining metric reliability within multimodal machine unlearning. This contribution focuses on understanding how well existing evaluation metrics perform in complex vision language models. This research reveals that standard unlearning metrics, such as forget accuracy and activation distance, often yield conflicting rankings for different unlearning methods. The analysis identifies two opposing clusters of metrics, highlighting a significant inconsistency in current evaluation practices. The study uncovers that metric agreement is significantly lower in multimodal VQA tasks compared to unimodal classification. This finding suggests that the dual image and text pathways inherent in multimodal models amplify the inconsistency of unlearning evaluations. The authors introduced the Unified Quality Score, or UQS, a novel composite metric designed to provide a more reliable and stable evaluation of unlearning performance. This system leverages Spearman correlation with an Oracle model to derive robust weights for its constituent metrics. Up next, our third paper out of 5, Vibe Econometrics and the Analysis Contract by Lydia Ashton from University of Wisconsin-Madison, School of Human Ecology. Let's break down its key contributions. The authors introduced the concept of Vibe methodology, arguing that AI-assisted methods democratize specific failure modes. This contribution highlights how AI outputs often fail to reliably signal invalidity, requiring expertise that the AI workflow bypasses. This contribution focuses on 3 critical failure modes exacerbated by AI: method data mismatch, confidence laundering, and invisible forking. The paper explains how AI industrializes the packaging of these issues, making weak analyses appear rigorous. The authors propose the Analysis Contract, a novel pre-commitment framework designed to address the challenges of AI-assisted causal analysis. This system leverages principles from pre-analysis plans and the causal roadmap for AI settings. This contribution details the 3 essential conditions imposed by the analysis contract before making a causal claim. It requires a method data contract, a thorough data audit, and a pre-commitment statement defining what would count as a disconfirming result. Up next, our 4th paper out of 5. Your language model is its own critic. Reinforcement Learning with Value Estimation from Actors' Internal States by Yunho Choi and Yohan Zhou from Seoul National University. Let's break down its key contributions. The authors introduce policy optimization with internal state value estimation, POISE, a novel approach that significantly reduces the cost of baseline estimation in reinforcement learning with verifiable rewards, RLVR. This system leverages the policy model's own internal signals, already computed during the forward pass, to obtain a baseline at negligible additional cost. This contribution focuses on the core mechanism of POISE, where a lightweight probe predicts the expected verifiable reward. The probe utilizes hidden states from the prompt and generated trajectory, along with token entropy statistics, and is trained online alongside the policy model. To maintain gradient unbiasedness when using trajectory condition features, the authors introduce a clever cross-rollout construction. This method ensures that each rollout's value is predicted from an independent rollout's internal states, preserving the integrity of a learning process. POISE significantly enhances training efficiency and stability by estimating prompt value using only a single rollout. This enables higher prompt diversity for a fixed compute budget, which in turn reduces gradient variance for more stable learning and eliminates overhead from sampling costs. Up next, our 5th paper out of 5. Hard to read, easy to jailbreak. How Visual Degradation Bypasses MLLM Safety Alignment by Zixue Song and Qi Zhang from AGI Lab, Westlake University. Let's break down its key contributions. The authors identify a critical vulnerability in MLLMs that process text as images, showing how lowering image resolution inadvertently bypasses safety alignment, even when the text remains legible. This contribution focuses on explaining the underlying mechanism, hypothesizing that the effort required to decipher degraded visual inputs causes cognitive overload, which diverts the MLLM's attentional resources away from safety auditing. The authors propose a simple, structured cognitive offloading strategy, which mitigates these identified risks by enforcing a serialized pipeline to decouple visual transcription from safety assessment. This work provides critical insights for the secure design of future MLLMs, highlighting a significant risk inherent in vision-based compression paradigms. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.